Now, ChatGPT and GPT models are incredible. You can have a chat conversation with them. They can, provide you the right answer to your questions. They also take into account the context, which is what you guys talked about before the question that you're asking. Maybe you asked it something, 30 minutes ago in the conversation. It will still remember that. But there's one limitation that all of these models share, and that is the fact that their context window, essentially their memory, is limited. Now, depending on the model, that limit is going to be different. But the fact of the matter that they all have a limit. And what this means is that, yes, you can have a basic conversation with them. They'll be able to remember what you guys talked about maybe 10 minutes ago, 15 minutes ago. But you can't feed it a lot of information and then ask questions about, okay? You can't give it like a 300-page book or like, a 2-hour YouTube podcast video and expect it to kind of know exactly what happened where, because it simply does not support that amount of memory. There's actually a very, very useful solution to this problem that you can implement in all kinds of applications and in all kinds of use cases. And so in today's video, I'm going to be showing you exactly how to solve that problem. And then later in the video, I'm going to be showing you a proof of concept app that I built that allows you to essentially have a Q&A session with a particular podcast episode, a very, very popular podcast episode, which you wouldn't be able to do if you do not implement this solution. Now, before we get started, as always, all the apps that I built on this channel are going to be available to view and or clone from my Patreon page. And you can see the link and perhaps join my Patreon community in the description below this video. So like I mentioned at the beginning of the video, these models have limits, okay? So you cannot store large books or long video content or long audio content. And the solution to this is that we need another system to help us store all of this extra stuff. And the way we do it is by implementing something called vectors and embeddings. Now, the first thing that you have to understand is you have to take all this content that you're trying to create apps around, right? So whether it's a chat bot or something else, and you have to convert it into numbers. And the reason we have to do it is, generally speaking, text for us, human beings, is relatively easy to understand and kind of make sense about, at least if it's in the languages that we understand. Whereas for computers, text doesn't really mean anything. Computers are really, really good with numbers. And so once you take all this text and you translate into numbers, some special numbers, it's going to be a lot easier for computers to kind of understand what's happening. The first thing that we need to do is we need to take the text that we're actually looking to kind of create, apps around, and we need to convert it into something called a vector. Okay, so here I have some text, and here I have an example of a vector. Now, what is a vector? Well, a vector is actually very, very simple. A vector is an array of numbers. In this case, we have an array, which is multiple numbers. And in this case, we have numbers that are, not whole numbers, right? These are numbers with a decimal point. So this is like minus 0.00 something. This is, positive 0.00 something. This is minus, etc., etc. Now, it doesn't really matter what these numbers mean, right? You don't really need to get or understand what these numbers mean. You don't really need to know that, this is a negative, this is a positive, this is a positive, this is negative. It doesn't really matter. Now, these vectors are not just an array of random numbers, right? These are not numbers that were generated at random, okay? These are numbers with a purpose. There is a reason that the numbers you're looking at here, are exactly the way you see them, because this is not just any vector, right? This is not just, any array of numbers. This is actually an embedding. And so what we are doing here is we're taking this text that we want to create apps around, whether it's a podcast episode or a document or something, and we need to split up this text into smaller pieces, okay? Now, this could be paragraphs, or this could be sentences, okay? It really depends on the kind of apps that you're building. In the app that I've built, I decided to split this up into sentences, okay? Because I'm analyzing a podcast episode, and it makes a lot more sense to kind of split it into sentences, because that way I can better understand what each person said, and kind of create a context around. Now, after you split it into sentences, the next thing that you need to do is you need to get an embedding for that specific sentence. Okay, so what is an embedding? Well, embeddings are actually very, very interesting. And if you Google for OpenAI embeddings, remember, OpenAI is the same company that released, GPT-3, ChatGPT, GPT-4, etc., etc. They also offer an embedding service, right? So you can kind of read about embeddings and what they are. But really, the simplest way to understand embeddings is that if you give a text, they get you back with a list of numbers with a vector, and what that vector means is essentially it's a position of that text in relation to other positions of other pieces of text. Okay, these numbers by themselves do not mean anything. It's only when you compare a set of one vector to a set of another vector, that's when things start to make sense. Another way to kind of understand it is, let's say you're in a new country, in a new city, in a new neighborhood, and that particular city has various points, and the locals may not know where specifically that point is, but they will know where that point is in relation to another point. That's kind of the way that I understood it, and that is kind of the way that may make sense to you, right? These numbers by themselves don't mean anything, but they do make sense when they are compared to other numbers that were generated from OpenAI embeddings. And so what we need to do is we need to take all of the text that we're looking to analyze, and we need to create embeddings for it. And once we have embeddings, now we can get a computer to compare one piece of text to another piece of text. And now we can do amazing things. And that is why I said in the beginning is that you can't really take two pieces of text and compare them. You can only do it once everything is in embeddings form, okay? And so here's kind of the main architecture, right? We're taking a piece of text. In this case, I'm splitting it by sentences. And then for each sentence, I'm getting an embedding. Now, we can get all of these embeddings, and you can, have all these embeddings. But if you are doing a lot of text, right, you want to analyze like a big book or like a long, YouTube movie, or like, a whole series of podcast episodes, typically you need to store these embeddings somewhere. You need to store them somewhere. And not only will that system allow you to store these embeddings, it will also make it easier for you to compare different embeddings in order to figure out like different things, different contexts around different questions, essentially to give you answers to the questions that you're seeking. And this is where we're going to be using another backend tool called Pinecone. And Pinecone is essentially a service that allows you to do interesting things with embeddings. It's essentially an embeddings database. So you can get your embeddings from, somewhere like OpenAI, and then you can store them here. And then once you have them here, you can compare different embeddings. You can, delete embeddings, you can update, you can insert new embeddings. You can do all kinds of interesting things. And that is exactly what I did. And then this last step, you're going to have your app. And if you're building like a chatbot, you're going to have various queries. And what you're going to be doing is you're going to be taking the queries, which is just text, and you're going to be converting it into an embedding. And then you're going to take this embedding and comparing it with all of these different embeddings that you've stored before as part of that initial document load. And then you're going to get various matches that you can show to the user and tell them, hey, well, this is what we found based on your query. Essentially, this is what happened when you entered the query. We converted into an embedding, and then we compare different embeddings, and we found these results that are the most closest to your query. Okay, and so this is a high level architecture of everything that you need to do in order to create a so-called long-term memory for your apps, long-term memory for your chatbots or different kinds of apps that you're going to be building. All right, so now that I've shown you the architecture here, let me show you exactly what I did step by step in order to create an interesting app around a very popular podcast episode. And so what I wanted to do was I wanted to create a chatbot around this episode here. This is the Joe Rogan Experience number 1470. This is an interview with Elon Musk. And the reason for that is it has a lot of views. So a lot of people have heard about it. So I thought it would be a good example. Now, the first thing that I did was I got the audio transcript for this episode, right? You can get audio transcripts of YouTube because they have subtitles and things like that. And the next thing that I did was I took that transcript and only used the first 10 minutes of that episode. Okay, so when you download the transcript, you're gonna have timestamps and you can just pull out the specific time frame that you want. Okay, and the result was this piece of text here, right? This is the beginning of the podcast. You know, he says, welcome back, here we go again, great to see you and congratulations. And this is the transcript of the first 10 minutes of this episode. Now what's interesting about that is if you copy this transcript into an app that counts words, you can see that this is almost 5,000 words, and this is more than, you know, typical models right now can support. So you won't be able to do it with like ChatGPT right now. The next thing that I did is I went to Pinecone and I created a free account. They actually have a generous free plan that you can sign up to and you can start using and kind of playing around with them, right? So once you like into Pinecone, you're going to be on this page here, right? And this is where you're seeing your indexes, right? So the next thing that you want to do is you want to go to indexes and you want to create an index. Now, when you're creating your index, there's a couple of things that you should be paying attention to. The first is the name of the index, right? This could be anything, anything that you want. And the next one is dimensions. Now, dimensions, you have to get it right. And dimensions will depend on, you know, the format of your data, right? So if you are getting your data as an open AI embedding, remember, we talked about this. This is an open AI embedding, right? This is not just any numbers. This is not just any vector. If you go into open AI embeddings, you're going to see that if you're using this model, and they actually recommend using this model right here, you need to see that it has 1536 output dimensions, and this is what you're going to be entering here. This is what it says dimensions, so you're going to enter 1536, and then once you do that, you just, you know, enter starter, since I'm on the starter free plan, and you're going to create an index. Once you create an index, you're going to have this index right here. Then you can click on it, and now you can send data there that you can query later on and compare and do a lot of interesting things. Now, once you've created your index, the next thing that you need to do is you need to load it with data. An empty index doesn't really do us any good. We need to load it with data, and we need to load it with data that we're actually interested in order to kind of query that data and compare it with other things that, you know, maybe the user is entering or anything of that sort. And so if you click on your index, first of all, you can see that I already loaded with data. So I have 481 vectors, and this essentially means that I have 481 sentences that I got my embeddings for, and I loaded up with this. So I have 481 data, you know, vectors, embeddings for each of the sentences. And so if you scroll down, you can see you have upsert, query, update, fetch, and delete. Now, upsert is an interesting one. Upsert means that it will either update if that data exists, and if it doesn't exist, it's just going to insert data. And this is exactly what you want to do. And so you can easily do it using a file that you can upload. You can generate a file of your data, or you can do it using an API, right? So you have your API key, and this is what it expects, right? Vector, ID, metadata, and the actual values. And this is going to be your open AI embedding here, okay? And so I did it using API, right? So if you come back to my client here, right, the first thing that I did was I connected to OpenAI's embedding, and you can do that using their API right here. It's all here. But essentially, the way you do it, you send them a model, you give it input, and you send it to this URL. So I can say, well, I'm using this model, and they recommend that everyone uses this model. So that's probably what you're going to be using as well. And the input could be any sentence. Okay, so for instance, I have a sentence here, I don't like pizza. And if I execute this request, I'm going to get this response here. Now, once I have this embedding here, what I want to do is I want to go back to Pinecone and I want to send this embedding. But not only the embedding, I also want to give it some information, right? I also want to, you know, give it some information so that I know later on what this embedding is about, as you're going to see. So I'm sending this embedding, and I'm also giving it a little bit of metadata. So the ID is like sentence 001. And the metadata is the name of this sentence. Because later on, when I query these embeddings in Pinecone, not only will I get back the embeddings, but I will also get the actual, you know, the text that I'm interested in, as you're going to see a little bit later. And so I actually had ChatGPT write me a quick script that allows me to take that transcript of the podcast, create embeddings for it, and then send all of these embeddings to Pinecone, and I'm gonna have that script available for my Patreon subscriber. Now, after I had all of these embeddings in Pinecone, it was time to build the app. So let me show you the proof of concept app that I built, and then I'm going to show you exactly how I built. All right, so here's the app, and on the screen we have different knowledge bases that you can query. And right now I only have the Joe Rogan podcast, and in fact I only have the first 10 minutes of that Elon Musk episode. So if you click here, you can actually query different things based on that episode. And so now we can pull up that transcript and we can ask the bot various things about the specific episode and see what kind of answers it can come up with. So here's the transcript. And I think one thing I noticed was Ellen's opinion when it comes to Warren Buffett, right? So he says, so let me say Warren Buffett, for example, and to be totally frank, I'm not his biggest fan. This is what he said. And if we take and copy Warren Buffett, we can, write a question. Does Ellen like Warren Buffett? Right? We can send and we can see the result that we are getting right here. So this is what the result we got. So let me say Warren Buffett, for example, and to be totally frank, I'm not his biggest fan, which is exactly what he said here. And so it picked out, a sentence that's closest to what my query was. And this is the response. And really, this is exactly right. This is exactly what we were looking to to get. This is the correct answer. Another thing that we can ask it is about SpaceX or Tesla. Okay, so for instance, SpaceX. What about SpaceX? And this is the response. SpaceX and Tesla are by far, the most amount of like brain cycles. And this is this line right here. Okay. Now there's Tesla also. How about Tesla? And we're getting the same line because this specific sentence, according to the embeddings and all the algorithms, all the math, this is the closest to this one right here. We can ask it something else. Maybe deep brain stimulation. What do you think? What does he think deep brain stimulation? Okay, I would like deep brain stimulation but I think for Parkinson's, it has really changed people's lives in a big way. Okay, so we can search for that. This is right here, deep brain. We can search it right here, Okay, I would like deep brain stimulation. And so it understood the query, but it did not select the other sentences that had deep brain stimulation as part of it. For one reason or another, it decided to select this one. And I'm going to show you exactly why it did that. Now, let me show you how I build this app. And then later in the video, I'm going to be showing you an important thing that you need to understand that's going to make this app 10 times better than it is right now. So here's how I build this app. I build it using Flutterflow, which is right now one of my favorite no-code builders because it allows you to build apps very, very quickly. Now, the first thing that I want to show you are the API setup that I have here, right? So if I go into my API setup, I have two API calls. I have one in order to get the embedding, and I have one in order to query the embedding. And that is exactly what you're going to be doing, right? As the user is entering text, right, their query, whether it's a question or statement or anything, we need to take that text and we need to convert it into an embedding, right? So this is what this API call is doing. And the next thing that we need to do is we need to, once we have that embedding, we need to query our database for other pieces of text, other embeddings that are similar to it, okay? So this get embedding, this is just this API. This is OpenAI API, the one that I showed you, the one that, I made calls. I have my key. This needs to be your own key, obviously. And what we're doing is we're passing in the message, right? Because this API, it only needs a couple of things. It just needs the model and the input, right? So I have the message, but if I go to the variable, I have the message, but in my body, my model is fixed and the input is the message. So the only thing I'm doing is I'm sending the message. This is probably one of the simplest APIs I've ever worked with, right? You just need the model, which is always going to be this one, at least right now. This is what they recommend, the company. And the input is going to be your text message. So the message is the one that they're entering in the text box. I'm going to show you in a second. And we get an embedding back, right? So we get an embedding back and then I pull it in here, right? So if I do something like, do you like pizza? I do a test API call. I get this embedding and I go in here and I need to pull up just the embedding, right? This data embedding. That's all I care about, right? This vector, right? This essentially this array of floating point numbers. That's all I care about. And then I have another API call. And in this call, we need to query that embedding in order to get other embeddings that are kind of similar to it in order to give the person the answer, okay? And so here I'm using the API for the Pinecone. And if you go back to my Pinecone dashboard, you can see that I have this query and you can see a sample API. You have, query results, and this is your sample command. That is what you're doing. You're essentially querying, and you're going to see your results here. And so you can send a request and get a response. That is exactly what I'm doing. So if you go back here, this is my specific URL for that specific index. And then I'm sending in the headers. I have the body here. This is all, in the API documentation. And I'm asking for 5 results because, it's going to give us the results, but not one result is, the authoritative results, right? It's going to give us some results, but they're going to be sorted by what it thinks is the best fit, the best match. So I'm asking for 5 results. You can ask for 10 results or more if you want. You can ask for 2 results. And then I'm sending the embeddings, okay? And what I'm getting back, right, if we go in here, what I'm getting back is I'm getting back a result that looks something like this. I'm getting back, a bunch of things. So if you go back to my app, this is my query, and this is the result that I'm getting. So if I send out some embeddings here, some query that was translated into embeddings, in this case, I'm getting sentence 214, and I'm getting a score, right? So the higher the score, the better that it thinks the match is for that specific query. And these are the values, right? These are the embeddings. And so once I have my embeddings, I no longer care. I don't really care about these values because remember, I was sending in the sentences, I was sending in the text when I was creating embeddings. So if we scroll down, you can see that this specific embedding, it actually has metadata, and the sentences, what's a dream house for Elon Musk? This is the sentence for that specific embedding. So I don't need to, I don't need to kind of worry about the embedding here. I have the sentence back that I can start to use and show the person. Now, I also connect to a Firestore database in order to store the chats and the messages. I'm not using the users right now, so that's just, created for me. But I have chats where I have the name of the chat, the image, which is the, the logo, maybe a podcast logo or some, book logo or something so that it's easily displayed on the main page. And then I have the messages, and this is a sub collection of chats. And I have a timestamp, I have the name, and I have the sender, okay? And so now that you've seen kind of the data structures, let me show you how the app works. And definitely stay tuned until the end because I'm going to be showing you a little technique that's going to make your app 10 times better than it is right now. So when this app loads, we're showing this chat screen and we're doing a query from our Firestore database. We're just doing a chat query. And so when the user clicks on something, they are redirected to the chat's messages, okay? And this chat's messages is just a way to show the messages. So depending on if the message is from AI or if it's not from AI, it's going to show it in different parts of the screen. So the AI messages are viewed on the left-hand side. The user messages are viewed on the right-hand side. And the way I'm doing is, well, first I have a list view. And what I'm doing here is I'm pulling the messages, right? I'm using the chat ref from the main page, that specific chat. I'm passing that a reference, and that way I can pull up the sub-collection of messages. And what I'm doing here is I have a stack because I need to display these rows depending on if they are, if they're being sent by AI, by the bot, or they are being sent by the person, like me in this case. So I have 2 rows inside a stack. So this is going to be shown selectively. Okay, so row other, right? If you come to conditional visibility, which is a way to display something based on a particular condition, I'm saying if the sender is AI, show the row on the left hand side. If the sender is not AI, right here, center, this is me, this is the user. Show it, if it's not AI, show it, display this row, which is going to be displayed on the right hand side. And so if I show this in AI Builder, you can see this one here. If I turn this off, you can see this AI side here. This is kind of how messaging apps work, right? The messages that you send are, typically show on the right hand side. And the messages that the other person sends, they're shown on the left-hand side. This is kind of how things work. And this is exactly how I have it set up here. Now, the most important thing here is the send button, right? So what do? We have 5 actions here. And so the user types a message. We're going to open this. And the first thing that we need to do is we need to save that message to Firestore, okay? Regardless of what the user type, Regardless of what happens, we need to save that message. This is what we're doing here. So we're creating a document in the messages sub-collection using the chat ref as kind of the main collection. And we're sending in the timestamp, the name, and the sender. The sender is actually the logged in user, right? Display name, authenticated user. So you have to be logged in order to use this app because we need to know who you are. And then we're doing a backend call. So the user enters a query. We need to get embeddings for the query. You can't do anything with text unless we can get the right OpenAI embeddings. Because we already stored all of these embeddings for our document, we're going to get OpenAI embedding for this specific query. So what I'm doing is I'm doing an API call and I'm sending in the message and I'm checking if it succeeded. If it's already succeeded, then I have the embeddings. In that case, I can do the second call, which is querying our Pinecone database for that embedding or other embeddings around. And so what I'm doing here is I'm taking the embedding that we got in the first step from OpenAI and I'm sending these embeddings to Pinecone using that API call that I showed you a little bit earlier in the video. And so I'm sending this embeddings right here, and I have a custom function that essentially takes the embeddings as a string, just as a string, and converts it into a list of double, which is what that API call expects. And here I'm passing this data embedding. This is the result from the first function as the input to the second function. And then I'm checking if it succeeded. If everything is fine, all I'm doing is I'm creating the document. This is the response. This is the AI document. I'm saving this document as AI. And so I'm setting the current time. I'm setting the name of the message as result that we got back from the second API call. And I'm setting the sender as AI. And that way I can differentiate whether it was the user who sent the message or whether it was the AI who responded, who sent a response. And that way we can display them in different parts of the screen. And that's pretty much how the app works, because once you've stored all those embeddings in the system, you can ask the app pretty much anything, and it's going to give you the response to the best of its ability. Now, there's one thing that you can do that's going to make this app a lot better. Now, remember when we queried this app for various responses, and the fact of the matter that these responses are great, but they're not ideal. For instance, if we ask something like, what's Ellen's ideal house? Something like this, and we get a response. And so if we query this, we get a response like this. And this is essentially a line from the podcast, right? So if you search for Tony, you can see this is the line that we are getting back. Now, this is a nice answer, but this is definitely not the ideal answer. There are some things that you can do in order to get even better answers, like more ideal answers. And that is because when we query this system for answers, we are only displaying the best answer that it thought. And the fact is, it actually gives us multiple answers. So for instance, this query here, if you query a database directly, yes, you're gonna see this response right here. So if we scroll down, you see this response. This is the response that our app displays. But this is the best response. There are actually other responses that it came up with that are not as good as that first response. So if you go to the top, you will see that the first response, this is sentence 214, is almost 0.9, which is actually really, really good. But there are actually more responses, right? So if we scroll down, you're gonna see there are more answers that it actually came up with. So here's another answer. So what's more important, Mars or a house, right? So this is actually, it kind of has to do with house, right? They're comparing his house to Mars, but it's not as good as the previous question. And then we have another one. So if we scroll down, we're going to see more responses. If we scroll down, here's another response that came up. I was like, well, I like collect these little houses that I can build something, I don't know, artistic, like whatever. So this is his answer, right? So he's like, maybe he doesn't like houses. He's saying he was collecting, buying all of these houses, but now it's not something that he's into, right? So essentially from the system, we can get, many responses. We're just showing the best one in the app, but potentially we are asking for 5 responses. And so essentially what you can do is you can, ask it for 5 best responses, and then take those responses and you just feed them into ChatGPT and have ChatGPT creatively come up with the best answer. And this is exactly what I did right here. So here I have an API call, and this is exactly what I'm doing. I'm saying, you're my researcher assistant. First, I'll give you a question. Then I'll give you a list of different answers for this question. I want you to take into account the question and different answers provided, and then come up with your answer. Reply with your best opinion without quoting any previous answers you were provided, right? So essentially, that's what I'm doing. I'm giving it the question that the user entered, right? So in this case, the user wanted to know what's Elon Musk's dream house, and then I'm feeding it the 5 best answers that Pinecone, our embeddings database, our vector database, gave us back. And this is what it came up with. Based on the answers provided, it seems that Elon Musk is more interested in outer space and developing new technologies for his companies, such as SpaceX and Tesla, than in owning a dream house, right? And this is a much better answer than those 5 previous answers that were in the podcast, right? And this is exactly what a human being who kind of watched the podcast or read the transcript can, come up with, right? This is the conclusion they can possibly come up with. And so if you want to make a really, really nice app, you can potentially take, top 5 or top 3 answers, feed them into ChatGPT, and then use this as the reply. Yes, it's going to be better, but you have to do a little bit of work. And so if you want to build like an amazing app, this is exactly what I would do. Because right now in the app, I'm only displaying the top result. Okay, I'm ignoring all the other responses, but the prudent thing to do would be to take the other responses, whether it's top 3 responses or maybe even top 5 responses, or maybe even like 10 responses, right? I would probably do maybe top 5 and experiment it a little bit. Feed them into ChatGPT and get back a response formulated by ChatGPT with all the extra context. And that way you're giving ChatGPT just a little bit of context because you have all this data stored, and then ChatGPT is able to come up with really nice answers based on the context that you've gotten from your vector database. It's kind of the best of both worlds. And this way you can build a truly amazing chatbot or all kinds of interesting AI applications. Now, if you enjoyed this video and you're thinking to yourself, I want to build an app just like this one, I want to do exactly what you did, I want to do using a vector database and embeddings database, but I want to get a head start. And what you need to do is you need to view and or clone this app and modify it to your specific needs, to your specific requirements. And you can do that once you join our amazing Patreon community, because as part of joining our amazing Patreon community, you're going to have access to not only this app, you're going to get access to all the apps that I built on this channel, and you'll be able to view and or clone them very, very easily. Plus, you're going to get access to extra content such as Q&As, live streams, behind the scenes content, and our Patreon exclusive masterclass series where I do a deep dive on specific topics that the audience is interested in. So our community votes on a specific topic, and then I sit down and I do a deep dive video talking exclusively about this particular topic for our amazing Patreon subscribers. So if that sounds like something you want to be a part of, then definitely check out our amazing Patreon community and consider becoming a member. You're going to see a link to it in the description below this video. If you guys enjoyed this video, you should check out many of my other AI videos where you can build amazing apps using AI. And I'm going to link my entire playlist to this corner right here. So if you click on that corner video, you're going to have access to the entire playlist of my AI apps.